Hello guys, welcome back again to another video of your class 11 mathematics. In today's video also we're going to learn about the topic known as your limits and derivative. So which falls under your chapter 13. So let's begin. So today's video is all about your exercise 13.3, and before I start your 13.3, it's all about the topic known as your derivative. So let me just help you with the definition. So it's given to be suppose f is a real valued function, comma, the function defined by limit of h tends to 0, your f of x plus h minus f of x divided by h, where whenever the limit exists is defined to be the derivative of f at x and is denoted by f dash x. So the above definition of derivative is also called the first principle of derivative, which is known as, I can say, or thus, that is nothing more than f dash x is nothing more than your limit of h tends to 0, your f of x plus h minus f of x divided by h. Okay, so don't forget that the derivative is also known as your first principle, and the formula for a first principle is this one: f dash x is equal to limit of h tends to 0, f of x plus h minus f of x divided by your h. So that's all about derivative. Now don't worry, further on we're going to know what is derivative whenever you can solve the problem. So in the meantime, do remember that derivative, let me just write down here, derivative is denoted by f dash x, or I can say d by d of x. Okay, depends upon whichever we are derivating with. If I'm derivating with x, I'm going to write down that, and if I'm derivating with y, that will be your f dash y or d by dy. Now let me write down some important formula of derivative or for derivative something. So some important formula of derivative. The first one, do remember, d by dx of your x to the power n is nothing more than n x n minus 1, d by dx of constant. Your constant, it means rather than x, anything. Whichever you got, the answer will be nothing more than 0. The third one, I can say d by dx of your sine x, which is nothing more than your cos x. Number 4, I can say d by dx of your cos x, which is nothing more than minus sine x. And comes a very important rule. There are two important rules as a note you can write down. The first rule is known as your product rule of your derivative. Okay, so which is nothing more than d by dx of your uv. So if you can see, there is nothing between them, so that will be nothing more than u d by dx of v plus v d by dx of your u. That's your product rule. Then comes the next important rule, which is your quotient rule. Your quotient rule is nothing more than d by dx of your u divided by v. That will be v d by dx of your u minus u d by dx of your v divided by v square. So these are some important formulas. So you can pause the video and then write on this formula. All right, so let's begin with your exercise 13.3. First of all, let me start with your question number 1. Question number 1 is given that find the derivative of x squared minus 2 at x is equal to 10. Now, whenever it's given, find the derivative of. Basically, use the first principle. Okay, so what can I do over here is that I can simply say that let your f of x to be nothing more than your x squared minus 2. Now, let me write down the formula for your first principle. So the first principle formula is nothing more than your f dash x is equal to limit of h tends to 0, your f of x plus h minus f of x divided by h. That's your first principle. Then if f of x happens to be that, your f of x plus h is nothing more than then, okay? Instead of x, it's x, so there will be your x plus h, the whole thing square minus 2. So expand this one properly, so there will be x squared plus h squared plus 2xh minus 2. So I got till there. So what can I say? Then by applying the first principle, we get, first of all, write on the formula, f dash x is equal to limit of h tends to 0, f of x plus h minus f of x divided by h. Here also, our main objective is to remove the denominator because h tends to 0, and as I said, we don't want the denominator to be 0. So which will be limit of h tends to 0. I got this one to be x squared plus h squared plus 2xh minus 2, and I got this one to be minus x squared minus 2, and I got here divided by h. So let me go to the next page, which would be nothing more than limit of h tends to 0, what I got, okay, x squared plus h squared plus 2xh minus 2, and if I open up the bracket, that will be minus x squared plus 2 divided by h. Now just cancel the like terms. So what can I cancel over here? I cancel this and that. Again, I cancel this and that. So I'll get the answer, limit of h tends to 0. I got here h squared plus 2xh divided by h. Over here also, I can take yet the numerator, the value for h common. So which will be h plus 2x divided by h. What I can do, I cancel h and h. So which will be limit of h tends to 0. I got here h plus 2x. So the value for h happens to be 0. So which will be 0 plus 2x, which is nothing more than 2x. So in short, I got your f dash x is equal to 2x. But the value for x happens to be 10. Then your f dash 10 would be nothing more than 2 into 10, which happens to be 20. So that was the first question. Again, the same thing. Pause the video and then check once again if you didn't understand the question. Okay, so that's all about your question number 1. Now, in a similar manner, let me try the next one. Let me just go ahead and then do your question number 4. And let me begin with your question number 4, 2. Your 4, 2 is given to be something. Let your, and the question says I have to use the first principle. So let f of x is equal to x minus 1 and then x minus 2. Now, whenever you got problem like that, what I want to do is that I want you to simplify. So if you simplify this one, you'll be getting the answer x squared minus 2x minus x plus 2. So which is nothing more than x squared minus 3x plus 2. So I got this one. So then I need your f of x plus h. So that will be x plus h, the whole thing square, minus 3x plus h plus 2. So which is x squared plus h squared plus 2xh minus 3x minus 3h plus 2. So keep like that for timing. So I got till there. So what can I do by using first principle? By using first principle, we'll get the answer f dash x is equal to limit of h tends to 0, your f of x plus h minus f of x divided by h. Now again, the same thing. Our main objective is to remove this h because we didn't want the answer to be 0. So what can I do? I can simply go ahead with limit of h tends to 0, put on the value. So x squared plus h squared plus 2xh minus 3x minus 3h plus 2 minus, and f of x I got to be x squared minus 3x plus 2 divided by h. Now again the same thing, I'm gonna open up the brackets onto your next page. So which is, I got here limit of h tends to 0. Let me just check once, x squared plus h, okay. I got x squared plus h squared plus 2xh and minus how much? 3x 3h h squared. 3x 3h, is it minus or plus? Minus only. That should be minus, plus how much? 2. Then minus, if I open the bracket, it will be minus x squared minus 3 or plus 3x minus 2. Minus x squared plus 3x minus 2, and I got here divided by h. Now again the same thing, cancel a 1, which you can again cancel your x squared and your x squared, plus 2 and your minus 2, and minus 3x and plus 3x. Now I got here limit of h tends to 0. I got here h squared 2xh minus 3h divided by h. Now again the same thing, take the value for h to be common. So I got here h, so I got here h plus 2x minus 3 divided by h. I cancel h and h. So which the next step would be limit of h tends to 0. I got here h plus 2x minus 3. Now put the value for h, that will be 0 plus 2x minus 3. So the answer is 2x minus 3. So that's your answer. So that's anyone here, f dash x. Okay, so that's all about your question number 4-2. Now again in a similar manner, let us try to do a little bit complicated one, nothing more than exercise, sorry, question number 4. Let me do it 4. So it's again the same thing, let f of x is equal to your x plus 1 divided by your x minus 1. Then your f of x plus h would be x plus h plus 1 divided by x plus h minus 1. So again by using first principle, we get, so if I use the first principle, I'll be getting the answer f dash x is equal to limit of h tends to 0 f of x plus h minus f of x divided by h. Again the same thing, our main objective is to remove this h. Let me just do it over here. So I'll get a limit of h tends to 0 x plus h plus 1 divided by x plus h minus 1 minus x plus 1 divided by x minus 1, and I got here h. Okay, now look properly. Okay, the numerator, I'm going to take the LCM. So if I happen to take the LCM, I'll be getting the answer limit of h tends to 0. Let me just give a big bracket. I'll be getting here x plus h minus 1, and I'll be getting here x minus 1. So which one will be x plus h plus 1, and then I'll get here x minus 1 minus x plus 1, and I'll get here x plus h minus 1, and divided by h. So let me just write down properly. The brackets should not end here. The brackets should end over here. Yes. Okay, so I got till there. So in the next page, let me just multiply. So if I multiply, which would be limit of h tends to 0. Okay, let me simply multiply over here. Let me go to the next page. Let me just multiply over here and then simplify it and then go to your next page. So if I multiply, I'll get here limit of h tends to 0. Simply multiply this with this, so I'll get here x squared minus x plus hx minus 1 plus x minus 1 minus, given bracket, x squared plus xh minus x. Remember, I'm multiplying this with this with that, and this with this, and then got till there. Now I'm going to multiply with 1, so it will be plus x plus h minus 1. Close the bracket, divided by, now I got here this divided by, that means I can bring this one down, so that will be nothing more than h, and I got here x minus 1, x plus h minus 1. Okay, now again, just check whether you can cancel something or not inside the bracket also. If you can see, I can cancel plus minus minus. h into 1 is, this is your nothing more than I've done wrong. So remember, this into this is, I got that, but this into this, I should be getting here h. Yeah, that's correct now. So what can I cancel over here is, I can cancel here minus x and plus x, similarly minus x and plus h. So on to your next term, let me just write on here again. So I'll get here limit of h tends to 0, I got here x square plus hx minus h minus x square minus xh. Oh, I totally forgot about minus 1 also. Okay, let me again, sorry for that. Over here I got minus 1, I totally forgot it. So I got here minus x square minus xh, minus into minus is plus 1. I got till there. Alright, so I got here divided by h, and I got here x minus 1 and x plus h minus 1. Now again, same thing, cancel the 1 which you can. Over here also I can cancel your x square and your x square. This, and this with that. So let me go with the next page now. So I'll be getting the answer, okay, to be limit of h tends to 0. How much I got? Minus h divided by h, and I got here x minus 1 and x plus h minus 1. So x plus h minus 1. I cancel this and that also. So which is, I got here minus 1 divided by limit of h tends to 0. I got here x minus 1 and I got here x plus h minus 1. So just put the value for h, which will be minus 1 divided by x minus 1, x plus 0 minus 1. I got here minus 1 divided by x minus 1, and I got similarly x minus 1, which is minus 1 divided by x minus 1 the whole thing square. Again, let me check whether I have done something wrong or not. Yes, again I did a wrong thing. I got here plus. So minus into plus is, I'll get here minus. So if I got here minus, I'll be getting here minus, sorry, I'll be getting here 2, and that should be 2, that should be 2, that should be 2, and that should be 2. So therefore your f dash x, I got it to be minus 2 divided by your x minus 1 the whole thing square, and that's your answer. And for this question, I'm going to say once again, pause the video and then check properly. Alright, so in a similar manner, let us try to solve your question number 7. Question number 7, 1. I got here x minus a and then x minus b. Now the question says, for some constants a and b, find the derivative of. So over here is only given find the derivative of, so we don't have to use the first principle. So I'm just simply going to use the derivative that you have written down the formula for. Okay, so let me just say that let your f of x is equal to your x minus a and then your x minus b. So what can I do with the next step is, I'm just going to say differentiating, that is differentiation and derivative, they are same. So differentiating both sides with respect to x. So if I differentiate both sides with respect to x, I'll get here d by dx of your f of x. That's called differentiating. Okay, so which would be d by dx of your x minus a and then your x minus b. So d by dx of your f dash x. Always remember, your d by dx of your f of x is nothing more than your f dash x. That is known as your derivative or differentiation. Something. Okay. So I got this one, so I'll be getting the left hand side to be your f dash x, which we need. And for this one, if you can look, I got two terms and nothing is there between them. When I got two terms and nothing is there between them, I should consider this one to be your product rule, and this will be your u and this will be your v. So what is your product rule? According to your product rule that you have written down the formula, it's d by dx of your uv, which will be u d by dx of v plus v d by dx of u. The same thing I'm going to do it over here. So let me just write it nicely. So I will get here f dash x. So your u is x minus a and d by dx of your x minus b, and similarly plus x minus b and then d by dx of your x minus a. Now, if I solve this one, I'll get here x minus a, and the next thing I'll get here is d by dx of your x minus d by dx of your b, and similarly plus x minus b, and the next one I'll get here is d by dx of your x minus d by dx of your a. Now, as I said, and you can see the formula, I just simply say that whenever there is a constant term rather than x, that means d by dx of constant is nothing more than 0. Now, dx and dx I can cancel. So the first one I'll get here is nothing more than 1, and this is constant, so there will be 0, plus x minus b, and similarly this and this can be cancelled, so that means I'll get here 1, and then that will be 0. So why? Because this is a constant term, and the question also is given that a and b are constant. So which is nothing more than x minus a plus x minus b. So the answer would be nothing more than 2x minus a minus b. So that is your answer for your first one. Okay, and again I'm going to repeat, don't forget your d by dx of constant is equal to 0, and also d by dx of your x is nothing more than 1. Okay, so I got this one to be your question number 7. All right, before I go ahead with the next question, I just want you to learn one more step over here in this question is, I want you to omit this one in the exam also. Why is that so? Is because if you can just see over here, if you differentiate this and this, d by dx of x, how much we'll be getting? We'll be getting nothing more than your 1. And similarly, if I differentiate this with that, b is constant, so d by dx of constant is nothing more than 0. I'll be getting the answer directly. Similarly, if I differentiate this with this, I'll be getting the answer nothing more than 1. And if I differentiate this with that, I'll be getting the answer nothing more than 0. So you don't have to write on this step at all. Okay, so this step was just only for understanding. But if you think that no, I didn't understood and I have to go stepwise, you can always go in this manner. But I would simply say that you'll simply be wasting your time over here. All right, so again, same thing. Let us do the next question. Let me just do your question 7.3. Question 7.3, let me just say that is given to be, let your f of x is equal to your x minus a and then your x minus b. So same thing, differentiating both sides with respect to x, I'll be getting here d by dx of f of x, and I'll be getting here d by dx of your x minus a and x minus b. Now, if you can look, that's nothing more than, I would say, your quotient rule. Why your quotient rule? Because there's divided sign. So your quotient rule means d by dx of u divided by v. So which is v d by dx of u minus u d by dx of v divided by v squared. So your u is this and your v is that. So if I differentiate the left hand side, I'll be getting here f dash x, and to your right hand side, I'll be getting v should be up first, so x minus b, and then d by dx of your x minus a minus x minus a, and it will be d by dx of your x minus b divided by your x minus b, the whole thing square. Okay, I want to check once again, that's your u, that's your v, that's your v, that's your u, and that's nothing more than your v square, which is similar to that. You can pause the video and check once again. So the next step would be, so as I said, I'm going to omit that step, so I'm just going to differentiate directly. Okay, so it'll be x minus b. So if I differentiate this with this, I'll be getting the answer 1, and if I differentiate this with this, I'll be getting the answer 0, because a is constant. And similarly, x minus a, if I differentiate this with this, I'll be getting the answer 1, and if I differentiate this with this, I'll be the answer 0. So divided by x minus b, the whole thing square. So what can I do? I'll just open up the brackets. It will be x minus b minus x plus a divided by x minus b, the whole thing square. So your f dash x, I'll be getting the answer. X and x can be cancelled. So that is a minus b divided by x minus b, the whole thing square. So that's your answer. So same thing, you can pause the video and then check once again. All right, so let us do your next question. Let me just go with your question number 9, and let me go with question number 9 too. Your 9 too, again, same thing is given, then find the derivative of. So let f of x is equal to, I got here, 5x cubed plus 3x minus 1, and I got here x minus 1. So what I want to do is that I want you to apply the product rule again. So let me just say that differentiating something both with respect to x, I'll be getting here d by dx of your f of x is equal to d by dx of your 5x cubed plus 3x minus 1, and then x minus 1. So remember, that's your u and that's your v. And I hope you've written down the product rule at the formula page, so you can just check over there. Okay, so if you differentiate this one, you'll be getting the answer, your f dash x, and according to product rule, the first thing will be u d by dx of v plus v, and then d by dx of u. All right, now before I go with your next step, again, let me go ahead with the formula first. Remember, d by dx of your x to the power n was nothing more than n x n minus 1. Yes or no, that you have written down. So same thing I'm going to apply over here. So just check nicely. So I'll get here 5x cubed plus 3x minus 1. Then over here, if I differentiate this with this, I'll be getting the answer 1. And I differentiate this with this, I'll be getting the answer 0. Plus, I got here x minus 1. Now this one, okay, just check. This with this. 5 is constant, so let me just keep 5 at this. So 5 is there. So I'll get here d by dx of x cubed. So according to the formula, that will be 3x 3 minus 1, because the value for n happens to be 3. So which will be 3x squared. So same thing I'm going to write down over here. That will be 3x squared. Now again, plus your 3 is constant, so let's just write on 3 as it is. So if I differentiate this with this, that is your x, I'll be getting the answer 1. And lastly, d by dx of 1 happens to be nothing more than 0, so minus 0. So which would be, open up the bracket, so 5x cubed plus 3x minus 1, and simply multiply plus x into x, that will be 15x cubed plus 3x minus 15x squared plus 3. So if I do that, I will be getting the answer. 15 is 20x cubed minus 15x squared plus 6x and then minus 4. Yeah, that will be your answer. And what did I do wrong? That should be minus. Okay, so that's all about your question number 9.2. Okay, in a similar manner, let us solve the next question. Let's just go with your question number 9.3 again. Your 9.3 is, let me just say that, let your f of x is equal to x to the power minus 3, and I got your 5 plus 3x. Now over here also, you can use the product rule, or instead of using the product rule, you can simply multiply, because if you use the product rule, it's going to be lengthy. So I'll just say that differentiating both with respect to x. Okay, before I differentiate, as I said, just have to multiply, so I'll get the answer 5x to the power minus 3 plus 3 and x to the power minus 2, because 1 plus minus 3 plus 1 is minus 2 again. So if I differentiate both sides with respect to x, I'll be getting the answer d by dx of your f of x is equal to d by dx of your, I got here 5x to the power minus 3 plus 3x to the power minus 2. So okay, let me do this one slowly again. So 5 is constant, so bring 5 outside, so I'll get here d by dx of x to the power minus 3. Again, 3 is constant, so 3 d by dx of your x to the power minus 2. Alright, now again, let me just write the formula. So d by dx of x to the power n is nothing more than n x n minus 1. Now again, the same thing, so d by dx of x to the power minus 3 would be, minus 3 will come down, so x to the power minus 3 minus 1, so which is minus 3 x to the power minus 4. So the first one, I'll be getting the answer 5 and then minus 3 x to the power minus 4, and the next one, if I differentiate d by dx of your x to the power minus 2, that means your minus 2 will come down, and x to the power minus 2 minus 1, which is minus 2 x to the power minus 3. So the answer will be 3, and I'll get here minus 2 x to the power minus 3. So which is minus 15, and then x to the power minus 4 minus 6 x to the power I'll be getting the answer nothing more than minus 3. So what can I do more about this one is that in short, I'll get the answer 15 by x to the power 4 and minus 6 by x to the power 3, because a to very nicely, because your a to the power minus m is nothing more than 1 divided by a to the power m, which one I'm simply writing. So from here, what can I take common is the bigger power. Or, okay, before I go with step, let me just take the common. I think that will be better. So if I take the common, I can take 6 and 15, I can take minus 3 common. And similarly, between x to the power minus 4 and x to the power minus 3, minus 4 is smaller, so I can take the smaller one common. So which will be nothing more than 5, and I'll get the answer minus 2 and then x to the power, yeah, 2x only. So the answer would be nothing more than minus 3 divided by x to the power 4, and then I got here, okay, because I'm taking minus common, so that will be plus, so that is 2x plus 5. So that's your answer. Okay, and how did I got x to the power 4? You can just check over here itself. All right, that's all about your question number 9.3. Okay, if you didn't understand, so let us try one more question, similar manner. So let me do 9.4. Your 9.4 is given to be again same thing. Let your f of x is equal to x to the power 5 and then 3 minus 6x to the power minus 9. Now again same thing, I want you to multiply first. So 3x to the power 5 and minus 6x to the power minus 4. Alright, so again same thing, differentiating both with respect to x. So if you differentiate both with respect to x, I'll be getting here d by dx of your f of x is equal to d by dx of your 3x to the power 5 minus 6x to the power minus 4. So which is nothing more than 3, and d by dx of your x to the power 5 minus 6 d by dx of your x to the power minus 4. Now again the same thing, let me do it rough. So your d by dx of x to the power 5 would be 5 and then x 5 minus 1, which is 5x4. So I'll be getting the answer 3, and I'll get here 5x to the power 4 minus 6 there. So the next thing will be d by dx of your x to the power minus 4, which is minus 4x to the power minus 4 minus 1. So I'll get here minus 4x to the power minus 5. So over here, I'll be getting the answer minus 4x to the power minus 5. So 3 5s are 15, I'll get your x to the power 4, and 6 4s are 24, minus minus plus, I'll get your x to the power minus 5. So which is 15 x to the power 4 plus 24 divided by x to the power 5. So that's your answer of your f dash x, which is your derivative. So that's nothing more than your 9.4. You can pause the video and then check once again. Alright, so let's again do the similar type of question. So let me just go with your question number 11 and try to do with your trigger value. So the first one, 11.1, is given to be let your f of x is equal to your sine x and then cos x. Now before I begin with your sine x and a cos x, you should be knowing that your d by dx of your sine x is nothing more than your cos x, and your d by dx of your cos x is nothing more than minus sine x. So don't forget this too. Okay, now in a similar manner, I got f of x to be that. So what can I do over here is that the next step I can say is differentiating both with respect to x. I'll get here d by dx of your f of x is equal to d by dx of your sine x and then your cos x. Now, if you can see, nothing is there between them. So that's your nothing more than your product rule. So this will be u, this will be your v. So for your left hand side, I'll get the answer nothing more than your f dash x. So d by dx of uv, it means u, and then d by dx of your v plus v d by dx of your u. So I'm getting till there. So which is nothing more than sine x, and d by dx of cos x is minus sine x, and something plus cos x, and d by dx of sine x is nothing more than cos x. So I'll be getting the answer minus sine square x, and then I got here plus cos square x, which is nothing more than cos square x minus sine square x. And in trigo, we have learned that cos square x minus sine square x is nothing more than your cos 2x. So that's your answer for your question number 11.1. All right, now let us try to solve the same thing onto your next question. Yeah. So let me go with your question number 11.3. So question 11.3 is given that let your f of x is equal to 5 sec x plus 4 cos x. Okay, now again same thing. We know that d by dx of your cos x is your minus sin x, but your d by dx of your sec x is nothing more than sec x tan x. Don't forget this one also. Okay, so again the same thing I'm going to do over here is differentiating both with respect to x. So if you differentiate both with respect to x, we get your d by dx of your f of x, and I got this one to be d by dx of your 5 sec x plus 4 cos x. Now if I differentiate that, the first thing I'll get here is 5 is constant, so d by dx of your sec x, and similarly 4 is constant and d by dx of your cos x. So it will be 5 d by dx of a sec x is, as I said, it's nothing more than your sec x tan x, and d by dx of cos x is minus sin x. So I'll get the answer 5 sec x tan x minus 4 sin x, and that's nothing more than your f dash x, and similarly I got your f dash x. So that's all about your question number 11.3. All right, let's try to do the next question in a similar manner. Let me just go with your 11.6. So again, same thing. Let your f of x is equal to your 5 sin x minus 6 cos x plus 7. All right, again, same thing. Differentiating both with respect to x, we get, so if you differentiate both with respect to x, I'll be getting the answer d by dx of your f of x is equal to d by dx of your 5 sin x minus 6 cos x plus 7. So which would be f dash x. Now let me just try to do this one in a very shortcut manner. So if I differentiate this with this, how much I'll get? I'll get the answer, nothing more than 5 cos x, and similarly if I differentiate this with this, I'll be getting the answer, nothing more than minus 6 minus sin x, and lastly if I differentiate this with 7 is constant, then means I'll get the answer, nothing more than plus 0. So the answer would be 5 cos x plus 6 sin x. So that's all about your question number 11.6. And again, same thing, you can pause the video and then check once again.